Hello, good day. So today we are going to discuss about a topic from our Thermodynamics II, which is prepared by a student from the Technological University of the Philippines. So the topic to be discussed is about standard vapor compression cycle. After this lesson, our learning outcomes will be understanding standard vapor compression cycle and its components, and for us to understand VCC's concept to further perceive how it is applied. So, what is vapor compression system and how does it works? Vapor compression refrigeration system is a system that uses liquid refrigerant in a closed system which circulates the refrigerant through four stages in which it is alternately compressed and expanded, changing it from liquid to vapor. How? The compressor takes in a low temperature, low pressure refrigerant vapor and compresses it into a high temperature, high pressure vapor. The heat from the source boils off the refrigerant through phase change, heat transfer, and the low temperature, low pressure gas enters the compressor, completing the cycle. So this is what happens in some part of the SVC cycle. To further understand, let us move forward. We have here on our screen the melting of ice or the evaporating of ice. The concept here happens on our SVCC, specifically in our evaporator. So recalling the second law of thermodynamics, it says that heat flows from higher temperature region to lower temperature region. Our illustration here shows that the surroundings have a more higher temperature than ice, and the ice absorbs the heat from the surroundings, causes it to melt and later to evaporate. And the temperature near the ice obviously will also decrease. Standard vapor compression cycle. So we have here on blue our evaporator. It is where the absorption of heat happens, and this is where our refrigerant is located and evaporated, passing to our compressor, our condenser, to our expansion valve, and back to our evaporator. So SVCC is just one of the different refrigeration cycle, but its only difference is that SVCC uses a refrigerant that needs to undergo evaporation in order for it to cool an area. We will further discuss the components of our SVCC. First, we have here our evaporator. This is where the absorption of heat happens so that a specific area or a room will experience a cooler or a lower temperature. In short, this is where cooling happens. Next is our compressor. This is the device that sucks the refrigerant from the evaporator to decrease the evaporator pressure and passes it to the condenser. Condenser is also the high temperature heat exchanger where heat rejection happens and gas changes to its liquid phase. Lastly, the expansion valve, also called the throttling valve. To loop the refrigerant, we need to lower its refrigerant pressure, and we can only achieve it with the use of expansion valve. It is the device that regulates the flow of the system and decreases the refrigerant pressure for us to create a loop. There are four processes in the ideal SVCC. First is on the 1 to 2s phase, the isentropic compression. The entropy of the inlet fluid and outlet fluid are the same. Second, isobaric heat rejection, 2s to 3 phase, that happens in the condenser. As the refrigerant cools down, it remains its pressure or maintains its pressure. Next is the isentropic throttling. It is decrease in temperature and pressure, but enthalpy remains the same. Isentropic throttling happens in the expansion valve. Lastly is the isobaric heat absorption that happens in the evaporator. In this process, the refrigerant changes the phase from liquid to gas while pressure remains constant. To summarize what we have discussed, the vapor compression cycle involves four components: the compressor, condenser expansion valve or the throttle valve, and the evaporator. It is a compression process whose aim is to raise the refrigerant pressure as it flows from an evaporator. Thank you so much for watching this video. Hope that this video gave a little help on your thermodynamics journey.